My name is Alexander Nakhabov, and I'm Associated Professor and Deputy Head of Nuclear Physics and Engineering Department of Obninsk Institute for Nuclear Power Engineering of the National Research Nuclear University MIFI, Russia. So, in my today's lecture, I'd like to discuss with you a hot topic nowadays in nuclear power engineering, small modular reactors. But first of all, I'd like to consider prehistory of this area and experience of Russian Federation in this area of small modular reactors. And if we talk about small modular reactors, first of all, we should to remember about transport nuclear installations. So, transport nuclear installations means nuclear power used not for power generation, electricity generation, but to provide propulsion for ships, for example. And it's known that the first area of application of nuclear for transport purposes, really it was submarines. Submarines, of course, it's not civil, it's military application, but for this kind of ships, the advantages of nuclear power really were demonstrated much obviously. So, the first in the world nuclear-powered submarine was from United States, called Nautilus, and in 1954, she was commissioned in United States. Actually, for submarines, the main advantage of nuclear power is really unlimited range of ship because there is no need to refuel. And as well as for nuclear power installation, there is no need to use air for operation. So, you see on this slide the first big milestone achieved by nuclear submarine, Nautilus. It was the first ship in the world which reached North Pole under ice in 1958. Actually, Soviet Union was the second country who commissioned nuclear-powered submarines, and several years after nuclear submarines in the United States, the first nuclear submarine of Soviet Union, K3, was commissioned as well. And actually the same achievements were repeated about North Pole, and moreover, in 1962, the K3 submarine, first time in the history, reached North Pole under ice as well. So about how it operates for nuclear power installation, because I guess you know about principle of operation for nuclear power plants, but for nuclear transport installations, it looks similar, but of course with some differences. Actually, all part regarding nuclear island, nuclear power installation itself, reactor, all equipment of primary circuit and secondary circuit in general really is similar to big nuclear power plant, but the one big difference, of course, is size. Because for nuclear power installations, transport installation, there was no need to achieve big power. For ships, it's not needed. Of course, all equipment and size of all installation was really smaller than for big power plant. So you see on this slide primary circuit, and the main maybe difference with big power plant, it's so-called special pool around reactor, because reactor vessel with core nuclear fuel inside is constrained inside special pool with water, because first of all it's needed to provide radiation protection for crew. And in the secondary circuit, if in big power plants power generated, actually we have turbine connected with generator, turbo generator, to rotate this turbo generator and produce electricity. In ships, as usual, we can use a direct scheme when turbine through special gearbox rotates propeller, and in this way propulsion can be provided for ship. Of course, it's quite possible to use generator as well to generate electricity and use this electricity then for propulsion, not for power generation purposes. And if in big power plants the outside water from river, ocean, special cooling pond should be used to cool down condensers of turbine, in transport installations, the outside water, as usual seawater, can be used for the same purposes. And now I'd like to go to the next area, because nuclear submarines was the first in time area of application of nuclear transport installations in big scale. But the second one, and civil area of application, it was nuclear icebreakers. Because advantages of nuclear power for civil ships were big ones, not so obvious like for military applications, but nevertheless, first in the world nuclear-powered ship was commissioned in Soviet Union, and it was nuclear icebreaker called Lenin. You see on this slide. Idea of using nuclear power for icebreakers really was great because icebreakers were one, maybe the only class of ships with advantage of nuclear power so obvious. Because icebreakers, it's quite specific kind of ships for northern countries like Russia, Soviet Union, for Canada, for United States, for Northern Europe countries, because Arctic Ocean really is covered by very thick ice. And if we'd like to provide navigation in these areas, we should to use icebreakers. And problem is every ship we need to provide refueling time by time. For usual ships, it's not so big problem, but for icebreakers, it could be big problem because icebreaker could be frozen in the ice and refueling could be impossible. So using nuclear power really is great step ahead because in this case, there is no need to provide refueling. So this icebreaker was put into operation in 1959, and as I said, it was the first ship of this class. And on this slide, you see some records for this ship. First of all, due to using this icebreaker and next classes icebreakers in Soviet Union, it was possible to increase time of navigation, length of navigation in northern regions of Arctic from 3 months per year to 11 months. Actually, nowadays, due to using nuclear icebreakers fleets, actually it's quite possible to provide all around the year navigation, 12 months per year. It's very important, first of all, for development of Northern Sea route. And I'd like to say here, Northern Sea route, I guess as you know, it's a route in the sea from Europe to Far East, not through traditional ways, through Suez Channel and through Indian and Atlantic Ocean around Africa. Northern Sea route will go through Arctic regions, and really the main advantage of this route, because this route is 2 times shorter than traditional way from Suez Channel. But the big disadvantage, this way, big part of the year really is closed due to ice. So nuclear icebreakers is very important, especially for Soviet Union and Russian Federation nowadays, to provide navigation through this transport artery. Nowadays, actually, in Russia, there are several nuclear-powered icebreakers, and Russia is the world leader in this area. So on this slide, you see photos, how it looks like, appearance of icebreakers, and on one photo, you see as icebreaker really provide provision of usual ship through Northern Sea route. And you see one more records from another icebreakers. In 1977, icebreaker Arctica, first time in history, reached North Pole on the sea, not under ice. Actually, it was very big record because one more pole from geographical point of view was achieved in this way. And you see one more record, 2005, this icebreaker demonstrated one more record, 1 million miles run since commissioning. Of course, with refueling, but refueling for nuclear icebreakers really is provided once per several years. So let's go to SMR-related nuclear applications. Actually, in this short section, I'd like to consider small reactors, not the same type like nowadays SMR, but all these applications really provided some experience for Russia to nowadays construct and operate small modular reactors. First of all, I'd like to mention Bilibino nuclear power plant. Really, it is a small nuclear power plant with 4 power units of small power capacity, only 12 megawatts of electrical power for each unit. But very important moment that this power plant was constructed in north regions, Arctic regions of Russia, and is the most northern power plant in the world. As you know, maybe in 2025, this year, this nuclear power plant should be shut down because this power plant really ran for many, many years, from 70s. So nowadays, this power plant provides for Rosatom huge operational experience for nuclear power plants in very severe conditions. One more application, fast reactors, because in Soviet Union and nowadays in Russia Federation, fast reactors is one of the most interesting areas of nuclear technologies, and Russia nowadays is a world leader in this area. On this slide, you see series line of different fast nuclear reactor projects with sodium as coolant, from small prototypes to the big power plants. For our purposes, for small modular reactors, it's interesting because on this slide you see experience gained with BN 350, because this reactor was fast reactor using sodium, liquid metal as coolant, but this reactor was used not only to produce electricity, but to provide desalination as well. This reactor was constructed in desert area of Soviet Union, and for many years, this reactor successfully demonstrated this quality of desalination. Nowadays, desalination area is very important, and for many modern nuclear power plants and small modular reactors as well, it's discussed how to use this type of reactors to desalinate seawater for many regions in Africa and Asia, first of all. On this slide, you see, of course, these reactors are not small. These reactors are commercial and big power. Two reactors, fast reactors with sodium as coolant, the only one in the world of this power capacity, BN 600 and BN 800 megawatts of electrical power, constructed and operated in Russia. I'd like to add that BN 800 nowadays is a reactor which operates with mixed oxide fuel. It's a very important milestone in development of nuclear technologies. And one more predecessor of SMR, of course, floating nuclear power plant. Because idea was inspired by submarines as well, and idea was as follows. What happened if we construct a ship, but with reactors aboard? These reactors are not used to provide propulsion. Propulsion is provided by usual engines, but reactors really just based on ship, and this ship can be delivered in some point on coast, sea coast or ocean coast, anchored in special equipped bay, and we can really provide cables, electrical cables from this ship to the ground. And actually, in this way, we can get transportable nuclear power plant of small capacity to deliver power in some isolated far regions. So actually, geography of Russian Federation is such that a very big part of our coastline really lies on the north regions, Arctic regions, and Far East. And really, many of these regions really are isolated, not connected with grid, electrical grid of the country. So in 2020, the first in the world floating nuclear power plant, called Academic Lomonosov, was commissioned in Russia. So on this slide, you see details, technical details of this installation. And it's important to say, actually, there were two reactors, nuclear reactors aboard, and this installation was designed not to provide electricity only, but as well as to provide heat, because for northern regions, where weather is very cold, and it's important to provide really heat for district heating as well. You see design values for refueling is once per 12 years. It's very important. Moreover, refueling is sensitive operation with point of view of nuclear safety. So in this case, it's supposed to not to provide fuel in this region, but vice versa, to deliver it floating nuclear power plant, get back in the port and provide refueling in this place. So on this slide, you see photos of this floating nuclear power plant, how it looks like. And in the central photo, you see appearance of reactor installation. For small modular reactors of this type, actually, the main idea is integrity. Instead of big power plants, when we have primary circuit with reactor vessel, with steam generators, pumps, and parts of pipelines between all of these elements. In small modular reactor of this type, you see all installation is very compact. You see in the center reactor vessel itself, and around this construction you see pumps. As usual, steam generators can be included inside of reactor vessel as well. In this way, we can minimize size and weight of installation. We can simplify maintenance, and we can decrease significantly risk of leakages from primary circuit. On this slide, you see RITM 200 nuclear power installation. Actually, this installation nowadays in Russia is considered as prototype for land-based small modular reactors. And you see parameters of this installation. Very important moment for small modular reactors that this kind of reactor installation, RITM, really was used in icebreakers. And it means we start this area not from the scratch, but based on experience for many years operation in very severe Arctic conditions. So this installation really is optimized based on all this experience. Design service life is 40 years with possibility of extension. In this slide, you see how it looks like, floating nuclear power plant anchored in some bay. Of course, we need to provide special infrastructure, like special pier around, special technical buildings, technical equipment, but cost and time of construction of this equipment, of course, very, very shorter than for traditional nuclear power plant. So in this way, floating nuclear power plants have big potential to be delivered in many regions of Africa and Asia, and, for example, to provide electricity, and instead of heating, maybe quite using power for desalination, for example. So, actually, in this slide, I'd like to finalize my lecture. And in my another lecture of this year, I will consider more detailed SMR area and current status of this technology in Russia. Thank you very much for your attention.